Located 7,000 light-years from Earth, the pillars are part of the Eagle Nebula, which is just one of billions of star-forming regions in the universe. The pillars are towering clouds of dust and hydrogen gas.
If you remember the periodic table of elements from chemistry class, you have the light elements up at the top, hydrogen, helium, lithium, this sort of thing, and then the really heavy ones as you get lower down.
It's hydrogen, the lightest, simplest, most abundant element in the universe, that is the key component of stars. Within a nebula, clumps of this gas and dust slowly coalesce into smaller clouds over millions of years, pulled together by a very familiar force.
The same force that connects us here to the Earth, that keeps us on the Earth, gravity, is the same force that pulls things together in a way that gives us planets and stars and galaxies in the universe.
Gravity, in many senses, is the most important force in astronomy. And when gravity acts in the universe, one of the basic things that it produces is stars. Stars are sort of the most basic unit of mass that is produced when gravity pulls mass together.
Each contracting cloud can produce anywhere from a few dozen to thousands of stars. To form a star like our Sun, which is 1,000,000 miles across, it takes a clump of gas and dust 100 times the size of our solar system. These clouds start off their lives bitterly cold, with temperatures hundreds of degrees below 0 Fahrenheit. But as gravity fragments and compresses them, the heat begins to soar. Within a few 100,000 years, the cloud spins into a flattened disk. Gravity coalesces the center of the disk into a sphere, where the heat rises to a scorching 2 million degrees. This glowing system is now known as a protostar. 10 million years later, the searing hydrogen core of the fledgling star soars past 18 million degrees, and something incredible happens. The core becomes so hot it can sustain thermonuclear fusion.
Thermonuclear fusion. It's a lot of syllables, but it just means it's hot there, and small atoms become big atoms.
Hydrogen atoms are moving fast enough that they actually will fuse together and will form a helium atom.
It's this nuclear reaction that produces the energy to power the star throughout its life, giving it a constant source of light and heat.
It's self-luminous, generates its own heat, and that's the essence of what makes a star a star.